Hello, guys. Hope you all are doing good. Welcome you all to this second video of the data engineering series 2. So, we'll be covering multiple concepts along this interview series, and I hope you all enjoyed the very first video that was published last week. So, I heard good feedbacks from all from my team and from the viewers. So, hence, continuing to the second part today, and I hope you all benefit from this. Try to sit relaxed, take a coffee, come sit for 1 hour, and make sure you learn as much as possible. And good luck with all your data engineering interviews that's to be coming. Okay, so we will jump to our video straight away today. So what are we going to look in today? We'll be covering few of the SQL questions, a few data modeling questions, then about big data tools, and then we'll end it up with cloud technologies. So that is the agenda for today. So to start with our SQL questions, the very first question is, how would you use window function in SQL to calculate a moving average over a set of rows grouped by a specific column? Okay, before trying to code your answer or before you're trying to process, the question, try to understand or try to split the question into different parts so that you get the better idea out of the question. Right? So what are they trying to ask you? How would you use window function? So first thing, you're going to use a window function to calculate a moving average. So you're going to calculate the moving average over a set of rows grouped by a specific column. So you're going to group by a specific column with which you are going to calculate the moving average, and you're going to do both of these operations using window functions. Okay, before we jump to the coding or the implementation part, let's try to understand the syntax for your window function. Okay, so window function, what is a window function? So window function, you try to create a window. Okay, you try to create a window over your data set. So these aggregated values stay in your window column, or let's say, in other words, you have your primary column, or let's say you have your primary row. Okay, it's not column, sorry. Let's say you have your primary row. Compared to that row, you compare it with or calculate in relevance to the other rows within your data. Okay, so how do you do it? How do you try to implement window function in your SQL? The syntax is very simple. First of all, you are selecting the columns that are needed. Okay, in here I've given it as sample, column 1 and column 2. And then I'm applying a window function here. Okay, so window function, what can it take? So in this window function, what I have named, you can use different kind of operations like average, you can perform count star, you can perform lead, lag, sum, average. So these are different kind of aggregate functions that you have. So you can use that function. And over, so what does over mean? So over is where the window is created. So you want this function to be performed over a particular group of column. You need to trying to aggregate or calculate, and then you are also setting the frame from which rows to which row you want it to be. Okay, let's see here. So I'm partitioning by column name. Why am I using partition by? In simple words, or in my way, I would always say that when it comes to window function, we use it as partition by. When we don't use window function, in normal SQL or basic syntaxes, we would use group by, right? So what does a group by do? Group by aggregates your column, right? It combines your column, it merges your column based on the value that you set, right? It groups by the basic, the cardinality that you have in your column, right? Similarly, when it comes to window function, you have your partition by with which you'll be aggregating your columns within a window, okay? And then you're ordering it by whatever the column name that you want. So if it is numerical, it would be ordered based on numerical values. If it is by alphabetic context, then it would be ordered based on the A to Z format. And also you can set it as descending if you wish to. And then you have to set your frame value, rows between, and then you have to give the frame specification. Okay. And for this window function, I've given alias name, because whatever is getting calculated here, it has to come up, right? So it has to come up in your result query. So you set an alias name, and this is your table name from which you're running this SQL query. So let's see the code before I could show you in the implementation. So how would you use window function? So I've used window function in my code. I'm calculating a moving average, which I will show you now. And then I need to set rows. Okay. So between certain numbers of row, I need to calculate my answer. So first I'm selecting the column names. I want a region column. I want a sale date column, and then the amount column. Okay. And then I'm using a window function here. As I said already, you can see that average is a aggregate function, right? So I'm using average function over the column named amount. So amount is my column already here, right? So I'm going to use an average function over amount, which is my column name. So rounders, you're rounding up the average value here. Okay. So this is my function over. So this is where my window gets applied. So between what and how do you want it to be grouped by? So over partition by region, I'm grouping my data based on the region. Okay. Or in Windows function context, I could say I'm partitioning it by region. And then I'm ordering it by sale date. By default, you get ordered by ascending order. If unless you choose, you can set it to be descending. And then here is my frame specification, which is rows between two preceding and current row. So what does that mean? So let's say I have my current row. Okay, I have my current row. This is my current row. Or let's for simplicity, let's say this is my current row. Okay, what I have selected. So two preceding is one preceding, two preceding. Okay, so I want to compare it with or calculate along with two previous rows. Okay, preceding stands for two. Preceding stands for the previous. So I want it to calculate to be between two preceding and the current row. Okay, and here is my alias name. From which table am I calculating? From sales. And I'm also ordering it by region after I set my window aggregation. Okay, let's see that how it gets implemented in our MySQL workbench. Okay, I'm creating a database and I'm using the database data engineering. So I'm creating a sales here, sales table, and I'm inserting few records into it. Okay, so my sales table contains 4 columns. Those are ID, region, sale date, and amount. So my ID column is the primary key. Okay, and my serial is an auto increment value set by the database itself. And then I have my region column, which is taking varchar with 50 characters. I'm having my sale date column with date type data type, and then I'm having my amount column with numeric data type. Okay, I've created my table. Now I'm inserting few records. Okay, let's see after I insert my record how our table looks. So select star from sales, the most common query any data engineer would be aware of. So as you can see here, I've got my ID serial, so it's an auto increment value. And then I've got the region north, south, east, and west, my sale date, and the amount for each date for different region, right? So this is just a sample data that we have inserted. So don't worry that for a particular sale date, all you got sales was 100. Okay, so let's not make it a big deal. So it's just a sample data. So now here, I want to calculate it for moving average 3 days window. Okay. So as you have seen the code already, now let me run it. Okay, what has happened here? What have I done here? Okay, let's say I've selected my region column. It's my region column. I've selected sale date. Yes, I'm right. Then I have selected it by amount. So you can see my three columns name. Okay. And here is my fourth column. How do I know it's my fourth column? Because I've set an alias name to be moving average, which is coming up here, right? So this is one window function and it has got a name, and that's how you get it to be displayed in your result. So here I'm having the average of amount over the over partitioned by region. So I'm partitioning it for region. Okay, so instead of collapsing the rows, what this window function would do is it would not collapse, but instead it would derive a value or amount out of it. Okay, so in group by, if I would have run it, let's take the partition by way. Let's say I've run a normal query, select region, sale date, amount, and average amount as moving average, and then I'm saying group it by region. What would have happened? You'd have just got four, for what? For rows, right? So I want you to be interactive. So please do drop a comment, okay? So that I know that you all are listening to me. So four regions, east, north, south, and west. So I would have got only four rows. Why is that? Because rows would be collapsed when I run group by. So in here, instead of collapsing, it would get a value out of it. So I'm partitioning it by region. I'm right. I'm ordering it by sale date. So as you can see here, 1st of June, 3rd of June, 4th of June, 5th of June, 1st of June, 2nd of June, 3rd of June, 4th of June, 5th June. So that is how my data is looking in this one, which is right. So I'm saying rows between two preceding and the current row. Okay. So I want to calculate the moving average. So how I'm doing it, I'm setting a frame specification here. If you see here, this is my amount, right? It's my amount column. As you can see, it has 90, 110, 130, which is my sales amount. And here I have moving average. So you might be confused, why is amount different to moving average? I'm calculating it with the two preceding. What do I mean by preceding? So it's previous value, right? But it's two rows back. Okay, let's forget this column. Let's forget the moving average. Okay. For 90, you don't have any sales behind, so it's going to be 90, right? And for next day, you're having a sales of 110. So what would be the average between these 2 days? 90 plus 110 divided by 2. What does the value give you? 100, right? So this here is my moving average, 100. So let's say my third row is 130 for east. So if I combine all this, 90 plus 110 is 200, 200 plus 130 is 330, right? So 330 divided by 3 is 110. Okay, here is the interesting part. So I have 170 here, I have 130 here, I have 110 here. Okay, also I have 90 here. So this is where you need to be very curious and pay attention to know that how does this frame specification work. What is 170 plus 130? It's 300. 300 plus 110, it's 410, right? What is the average of 410? It would be somewhere around 136 point something. But because we have used round function here, our value is getting rounded. So it's not including 90, right? So it's just for two rows behind the current value. Okay, and that is how you calculate your moving average for two previous days. I hope you all understood this. Okay, so jumping to our next question, write a query. Yeah, before we jump, I have a few talking points to be discussed. Okay, so as you can see here, over function lets you compute aggregates without collapsing rows. What happens in group by? So when you use group by, it collapses all the rows and combines it, right? It combines it to be depending on the cardinalities of the column that we are grouping it by. But when you have over function, you don't get to collapse it, but rather aggregation happens. Okay. So partition by resets the window for each group. And in here we are partitioning by region, right? So we are partitioning it based on the region column. Then two rows between two preceding and current row gives third row sliding frame. So our window frame is for three rows. All right. So jumping to our second question, write a query using a CTE to find the nth highest salary in a company. What is a CTE? CTE stands for Common Table Expression. Okay. You might be asking, what is the benefit of a common table expression? So the major benefit of common table expression is that you don't create a materialized table, but rather when you use CTE, you create a temporary table. All right. So you're not wasting your storage space, and you're also giving a better performance because a temporary table is formed for each query and it gets computed straight away. Okay, you're not materializing. If you're materializing it, your query needs to access your database, have to fetch the data, and then it has to come up with some result. But when it is CTE, it creates a temporary table. So rather than accessing your database for your data set, it's going to make your query a bit inefficient, right? So that's how you do it. So CTE, and also one major benefit of using CTE is that your query becomes more cleaner. Okay, your syntax becomes more cleaner. For example, let's say I'm running a subquery. Okay, so if I use multiple subqueries, my query is going to look awkward, isn't it? Awkward in the sense you're going to lose your readability. You're not going to understand your code with as much as clear understanding, but rather it is all confusing. You're going to wonder for each subquery of what it is doing, and what calculation does it perform, what is going to be the result for each subquery. So it's going to be a bit complicated. But when you use common table expression, you're going to have better visibility of your table or your query, or you're going to have a better visibility of your code, which helps in turn to create a better code, right? So in here, before we jump, let's try to understand the syntax of common table expression. So how you write a common table expression is that first you have to use the keyword called with. Okay, with is your first keyword to create your common table expression, and then I have named it to be ranked, but you can use any name of your choice. Ranked is an alias name, not specifying to any column or any table. Okay, it is just an alias name. We are going to give it for the temporary table that we are creating, which you can see here. So this query or this result that is getting out of this table, it's going to have a table name called ranked. Okay, so ranked is our alias name for the table that we are deriving in this query. So with ranked as, this is our very first syntax to create a common table expression. And then inside this, you can run a query which will, get set of results. So in here, this is like as usual how you write your code. Select name column, salary column, and then you have your dense rank function over order by. So what does a dense rank do? So dense rank is another aggregate function or a window function, however you want to call it. So dense rank, how is it different to rank? I'm not going to explain that in detail today, but because that came in our interview series, I'll just give you a short note. So rank is where you get to skip your ranks. Okay, for example, let's say you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 students in your class. So when you run a rank function, and let's say two guys have got second rank. Okay, so how does the rank function work? It gives the first rank to the first person, second rank to the second person, second rank to the third person as well. Instead of giving the fourth person the third rank, it skips number 3 but gives number 4 to the fourth person, right? And when it comes to dense rank, instead of skipping any rank, okay, let's say the same scenario, two people have got the second rank, but instead of skipping it, the first person gets the first rank, Second and the third person gets the second rank, and the fourth person still gets to have the third rank. So it's dense. Okay, based on the term you have to make it very clear. Dense is where, what is dense. So dense is close by, right? So you don't get to skip any rank, and you don't ignore any values. So that is what dense rank function does. So you're implementing dense rank function over. Over is your window function syntax. Order by salary, and you're giving descending keyword so that you will get the salary in the descending order. And this is the alias name I'm giving to this column. So my dense rank window function, that is going to have a name called rank, RNK. Okay, because I cannot use RANK again here because it is one of the keyword in the MySQL database. And this is from the table called employee table. Okay, so with ranked, so ranked is my temporary name for this table I'm creating. Okay, and now see here what I'm doing. Select name salary from table ranked. Okay, this is my table, right? This is my temporary table that I've created. Now I'm running a normal query like how we used to run, right? Select name salary from whatever the table name, where is a, it's a filter clause. So what I'm doing here, now I'm trying to derive data from this query that we run previously using CTE. So I'm selecting name, I'm selecting the salary from this table, the temporary table that we have created called ranked, and I'm using a filter clause where RNK. So what is the RNK alias stands for? It stands for this window function that we have created, and I'm setting the rank to be 3. Okay, so it could be any value because the query didn't state anything particular. And what the query says, write a query using common table expression which we have created to find the nth highest salary in a company. So dense rank is going to give a number for the salary depending on, descending order, and then from that rank we are choosing the highest salary, which in our context we are selecting the third highest. Let's see how this can be implemented in our code for better understanding. So I'm creating a table called the employee, which has employee ID as a column name, name as a column, and salary as a column. So employee ID is of a serial type, which is auto increment value, and then it is our primary key for this table. And name is having a text data type, and salary is having a numeric data type. So I've created the table, and now I'm inserting few records into my employee table. As you can see here, it's Alice with 90,000, Bob with 120,000, and Carla with 105,000, Diane with 120,000, and Eve with 75,000. Let's see how our table looks here. So as you can see, Alice, Bob, Carla, Diane, Eve, along with their salary, right? So now I'm running our common table expression code or the script. Okay, I've chosen here the second rank, and that's why I could see my second rank. Let's see how our normal table looks like. So uh, 2% are getting 120,000, right? So that is our second highest. So what is our highest value? Oh yeah, so if you see here, we have got 105,000 because 120,000 is our highest salary, and I've put the rank to be number 2. Let's say I'm running 3, but before running 3, let's check our table. What could be the number 3 value? So as you can see, 120 is our first, 105 second. So what could be the next? The 90,000, right? I've set the rank to be 3, and let's see. Yes, it has given us the 90,000. So Alice is getting 90,000. So that is how you use a common table expression to find the highest salary in a company. Jumping to our third question. Oh yeah, before running to that, let's talk few points about it. A common table expression makes the intent crystal clear. So as I said earlier, common table expression makes your code look better. It gives a better readability. So in turn, what does it do? It gives an clear intention of why that script is particularly running. So dense rank function, it keeps the ties together. Row number function ignores them. So when you use rank function, you get to ignore the numbers or ignore the rank. In dense rank, though there are ties, you get to have the rank. Row number, it doesn't matter. It just gives a row number. It's just 1, 2, 3, 4, 5, no matter what order it is in or how the data is being provided. We have made it in a way that we have parameterized the rank function, because by using where clause we are parameterizing, right? So if I want ninth, I can give number 9. If I want the fifth highest, I can still give 5, right? So we have designed the code in a way that we could use it like a parameter. Jumping to our third question, how would you optimize a slow running query? So if it was me who is running a code, this is how I would optimize my code. First of all, I would check if there are index on the regularly used columns. Let's say there is one frequent column that you always choose to run your query. So what can you do is you can index that column. What happens while you create an index? So while you create an index, pointers are formed for your data. So pointers for your data in the rows get formed in your database. So when the query runs the next time, instead of accessing your data or doing a full table scan of your data, or let's say even the column, so instead of scanning the whole column, it gets to access the pointers that are within the database. So these pointers will have the information of where that particular data is. So instead of scanning the whole column or the table, using index will give you a better point or a pointer activity towards your data set, therefore improvising your slow running query. And then the most common query run by all the SQL developers, data engineer, data analyst, select star. But that is okay when you have a smaller data set or a smaller table. But because your data is going to be larger, because you're going to operate at a scale of multiple GBs or TBs, okay, terabytes or gigabytes, so you cannot take that flexibility of using select star, but rather you have to choose what columns do you need actually to get your query running. You need to select the columns that will actually help you to optimize the code better. So make sure you use only select with the necessary columns rather than it select star. For example, let's say your table has 15 columns and it has few million rows. Imagine the size of your table. It's going to be at least 2 GB, right? So if you run a full table scan for all the 15 unnecessary row columns, it's going to impact your performance. So choose wisely. So choose only the necessary columns. Filter early with where clause as close to raw data as possible. So where helps you to filter your data, right? So when you use a where clause, you're going to make sure that instead of the full table scan again, it's going to filter your data as early as possible. Let's say I have a table. Let's say one of the columns says region, and there are 4 regions, right? Let's say it's north, south, east, and west. When I use where clause and say where region is equal to south, so instead of scanning the full table, it's going to scan me only the data from the south, right? Let's say in other words, let's say your data is 2 GB of size. And with the 4 regions, let's say each region has around 500 MB of data. So when I run this filter clause and my region is to be south, so instead of scanning 2 GB of data, I'm scanning only 500 MB of data. So ask you a question, which is going to be better? Which is going to give you a better performance? Which is going to be efficient? It is going to be when you run a where clause selecting a particular region. All right. Next, use explain to identify bottlenecks. Example, full table scans, missing indexes, missing indexes, expensive joins, unnecessary sorts. So what do I mean by explain? So explain is a keyword that you use in your query before the actual syntax. Let's say you have a syntax of select star from sales. Okay, all you have to do is just put the keyword explain in front of this query. Okay, what does it do? So when you run explain and slash and then the syntax, you get to see that how is this code running, how is this code getting executed in your actual database. So it'll show you that if your data is getting full scan, it'll show you that if indexes are being used, or is there is not indexes for certain columns. It will show you how the joins are getting run in your query. Because let's say you don't always perform your query with single table, but rather you always will have multiple tables. You might be a data engineer or a data analyst, whatever in case, you will have multiple tables to be joined together in a query. So if you use this explain keyword, you get to see that okay, joins are getting performed and what kinds of joins are they, because in joins you have variety of types which will improve your performance drastically. So it helps to show you what's the joint. And why is it mentioned expensive? Because data gets shuffled. The more the data gets shuffled, it's going to be expensive, right? It's going to cost your memory a little bit of space and performance. So joins are very heavy because it's shuffle heavy workload. And then unnecessary sorts, so you get to see if you're doing any unnecessary sorts, or if your code is optimized enough to run with a better uh, optimized plan. Okay, so always remember to use explain keyword before your actual query syntax. And then update table statistics using analyze in PostgreSQL. dbms stats.gather tables stats for Oracle database to help the optimizer. So what do I mean is every database have an optimizer. So what does this optimizer do is it helps to choose the better join strategy. The optimizer helps you to uh, create a better plan for executing your code. So this analyze or dbms stats.gather table stats will update your table statistics, which in turn will help your optimizer, which is very beneficial and is present in all database. So how does it do? Because the question is, it updates your table statistics and it helps your optimizer. We have seen what an optimizer does. So how is this optimizer going to use your table statistics? What is table statistics? So table statistics are nothing but it's the information or a metadata information about your data. Okay, for example, a table statistics will have certain information like what are the row count of this data, so how many rows are present within a table, how many distinct values are present within a table, what is the max value, what is the min value. So these type of information gets stored in your table statistics. So if you update the table statistics, for example, let's say you have added a new index, let's say you have sorted your data now differently, but if you don't update your table statistics, it's not going to be aware that what you have changed, what is going to be the max value now, what is going to be the minimum value, how have you uh, grouped your data, how have you performed join. So the table statistics are not going to be aware. it gets it's not that necessarily you have to run it, but at a point of time there is going to be latency and your table statistics are not going to be updated. So it is always good to update your table statistics. Coming to our next point, denormalize if necessary for read heavy workloads. What do I mean by denormalize? So what is normalize? So normalize is where you break down a larger table into smaller chunks of table. Okay, in simple, you break the larger one to a smaller table, so that is normalization. So what is denormalization? It's just quite opposite and simple. This is where you combine all your smaller chunks of data or smaller tables to one bigger table. It's not necessarily one bigger, but the point is you combine all your smaller tables to make a bigger one. Okay, so you can denormalize your table for read heavy workloads in specific. Why in read heavy workloads specifically? Because let's say you want to analyze the data and you'll be having multiple tables within your data, right? So it's not always you're going to work with one data, but you'll be having multiple tables, and you have to perform a relational operation where you get to combine your different table and then derive some insights out of the data. So depending on your use case, you might have different numbers of table. Let's say bare minimum 3 table, and let's say your each table is of 2 GB in size. If you perform join and it is a costly operation, it is going to take too much of data shuffling, and then it is going to cost your performance, and it is going to be an expensive process or an expensive query. How can you make it better? How can you fix that? What you can do is, instead of joining the tables multiple times, you can denormalize the table and materialize it. And then once you materialize and when you run all these queries, it's not going to be expensive as you could have done with a normalized table. So try to do denormalization for your table if it benefits your company, or if it is actually necessary for your results or for the analyst team for the better insight. Use common table expression or subqueries wisely. Avoid materializing unnecessarily. Not always you have to materialize your table. Not always you need to get some data out of your table by running your query, and then you have to store it permanently, because your data gets refreshed frequently depending on your business, how it works. But let's say your data gets updated every once in every day. Okay, so you're going to have data staleness. So let's say there is a data analyst in your team. He doesn't want an old data, right? He doesn't want a stale data. He wants a data that is fresh, which is going to improve the accuracy, integrity, completeness of your data, whatnot. So you cannot risk materializing data every day, because let's say for every day you are materializing your table, it's going to take up the space, right? And there is no point in you doing that, because next day you have to again materialize something. So instead of doing that, what you can do is you can use subqueries and CTE. So what happens while you create subqueries or run your common table expression is, you create a temporary table, okay, from which your data will be queried upon. So I've already shown you an example above. So you have your common table expression code, you create a temporary table out of which you query again, and then you get a data, so you're not materializing it. So try to use CTEs and subqueries wisely instead of materializing. So our fourth question now: describe how you design a database schema for a large-scale e-commerce platform focusing on the order management system. Include considerations for scalability and data integrity. So the first part is, how would you design a database schema for a large-scale e-commerce platform? Okay, I'm going to have multiple tables because it's an e-commerce platform. What could be the common tables that we can have? We can have users table, we would have the product table, we would have orders table, and then we would have order items table, and then we would have payments table and shipment tables. These are just the basic or the fundamental blocks before you run an e-commerce platform, right? You need a database that has at least all these kind of tables, or in other words, these information at least. Okay, what could be my key columns? So users table will have user ID as the primary key. The products table will have my product ID as the primary key. And in my orders table, I can have my order ID as the primary key and my user ID as my foreign key, because an user is the one who orders an product, right? So you can have an user ID as a foreign key. Then you can have an orders items table, which is going to have both order ID and line number as your primary key. So it's a composite key. And then you get to have a payment table, which is going to have payment ID as your primary key and order ID as a foreign key. So for each payments, you get to have an ID, which is going to be a primary key. And then the order ID is from the orders table, because for each orders, you're going to have a payment, right? So order ID is going to be an uh, foreign key for this payments table. Then you get to have shipments table, which is going to have a shipment ID of its own, and it's going to be the primary key. And then the order ID, which is going to be your foreign key for the shipments table. A few notes on these tables. So users is going to have your account profile, who the customer is, what's his phone number, what's his address, what's his location, and all these sorts of account information. The products table is going to have the price of the product, the SKU number for the product. So that is for the product table. And then you orders table. So orders table is going to have multiple, you know, orders, right? So for orders, you have the current price, sorry, you have the status, you have the totals as well. So let's say I have 5 products ordered, and let's say each product is 200 quids. So what could be my orders table having it? It would say that, okay, this is the orders table and this is the status, if it has been shipped, or what is the process, what is the status of the order, has it been packed or has it been, taken to the review for the team, whatever it is. And then the totals, right? Orders table is going to have the quantity it has been ordered, the sale price, at what time the sale price, for example, we might have different discounts for different days. Let's say today is Monday, so I'm going to have a different price. Maybe tomorrow there is a new offer coming up and they might, increase the price. So a snapshot of the sale price for my order items. Payments table is going to have all your transactional information, depending on, it's for your transaction reference number. It could have the payment mode that you use. It could have the bank that it is corresponding to. So what is the mode of payments? So that's where the information for the payments table is. So then for the shipments table, you might have the carrier information. So who is going to carry, so what the ship company is, from which country is it being, shipped from, and you're going to have tracking information as well. So to improve the scalability, before running to that, you must know why should you increase the scalability. Large systems must scale to handle millions of customers. Let's say you started with 5 customers today, and tomorrow you're going to have, more people. The 5 people have referred, and it's going to be 10. Let's say you're having a popular function or a popular sale happening in your site, so you're going to have millions of customers. So you must be able to handle them. You might have a frequent transaction because you have millions of customers, and because there is frequent transactions happening, you might have high volume of reads and writes, right? So these are the few reasons you need to scale your system. And let's see how we have to scale it. You can use vertical split. So what is a vertical split? So vertical split is when you move all your read heavy catalog to its own database. Let's say your products table, okay? So products table is going to be a catalog of the same information almost. Let's say, okay, the products, for example, let's say I have a phone. So what company is it going to be? Let's say Apple. So what's the price? So what's the SKU number for this? What's the IMEA number for that? So IMEI number for that. So all these information about the product or the catalog is going to be the same, right? So what you can do is, instead of having all these table name in a same database, you can allocate a separate database for the catalogs or the products table. Okay, how does it benefit you? So in here, product catalog is a read heavy. You'll be running frequent joins and stuff, right? So it's a read heavy process. And order system is write heavy, because in orders it is going to tell what product is it, who has ordered it, what is the transactional status. So order system is going to have multiple write heavy operation. So what you can do is have a separate database, and then you have to put your product catalog into it or the orders table to it. Okay, so this reduces your, free because this reduces your, low this reduces your, what can I say, how can I put it, the dependency on your particular database. So that's the keyword I was looking for. So it's going to reduce the dependency on one database, which is, going to have a deadlock if there is too much of write heavy transactions happening. So I put in here, this reduces load on your main transactional database and makes the system more modular. Modular is, you're spreading it up, you're distributing the workload. So what you can do is you can have horizontal partitioning, also known as sharding or partitioning. So you're breaking the larger tables into smaller ones. So for example, let's say you're partitioning the orders table. How can you partition it? You can partition it based on the order date, and then you can use user ID as well for your partitioning, right? I've stated this as range partitioning and hash partitioning. So hash partitioning is where, you use hash values. The system uses hash function to partition your data, and range partition is where you have particular range provided with which the partitioning happens. Then you can use event sourcing instead of, say, status overrides for audit trail. So let's say you're uh, writing a data frequently to your database. Okay, so you're going to have different updates that's happening regularly. Let's say you're ordering a product from the famous e-commerce website. When you order, it says added to cart. So when you're looking for the order and when you selected it, it says added to cart. And then what comes next? So what says is make a payment, and when you make a payment, it says amount paid. What happens after amount paid? Order taken. So what happens after order taken? It has been parceled. So then it gets shipped. So once it's shipped, it says that ready for delivery. So all these rows are, all these information is going to get updated. So instead of changing the same row again and again, okay, pending, shipped, delivered, what you can do is you can store it as a separate event in a different row. Okay, so the key point here is, instead of altering the same row again and again, you can have a new row that has all these status written in it. So the major benefit is also you get to have full history, which is beneficial in audit purpose. Also, it has better performance because you're only just writing it frequently instead of updating the existing records. So how do you improve the data integrity in this? You can enforce foreign keys. Then you can use, for example, orders.customer id must exist in the customer's table. So orders items dot order id, which is a foreign key again, will be existing in orders table. Then orders items dot product id is going to be a foreign key in the orders table, and it will be existing in your products. Also in turn will show that the related records are existing, right? Because in customers table you're going to have the customer id who has made an order, right? So in orders table, if you have this information, you're going to know that who ordered from the orders table. So all these are interlinked, making it relational and trustworthy. You have to check constraints. For example, when an order is made, the quantity cannot be zero, right? For example, you need two chargers. So you cannot just select a charger for delivery and and the order wouldn't be zero at all, right? So there is no way the order is going to be zero. So make sure that you can set a check constraint for that order stable. Then also make sure that when you should maintain a consistency between the payments and orders table. When a payment gets succeeded and let's say the orders doesn't get created, or let's say an order was made but your payment wasn't successful or it was not recorded, it is going to impact the business, right? Also it is going to create a ruckus between you and your customer, right? So when an order is made, or the payment must be successful, and once the payment is successful your order must be created, right? So if it doesn't happen, it's going to be a big no for a company. Let's say the customer hasn't paid for a product, but if you're delivering it because it has been ordered, it is going to cost the company money, right? So it's going to impact the finance of the company. So there is two ways you can fix this problem. It's a two-phase commit. So what happens is, two phases two-phase commit is when both the payment and orders happen simultaneously. Okay? So if there is an orders, then there is going to be payment. If there is a payment, then there is going to be an order. So it's a two-phase commit. Okay, you're going to commit to the two different tables. And then you can follow outbox pattern, which is safer. So what happens in an outbox pattern? So you write both order table and a payment to a table. Okay, so you write the order as well the payment event, what has happened with the payment. So you write both in a table, and then you use a background job to process your pending payments. So whenever an order has been placed and the payment has been done, you write it to the same table, and then whenever the status is pending, you split it separately, so that there is no confusion between this table and this table. And you make sure that, because there is going to be atomicity, and you're going to ensure that the data integrity is secured. And then also you can set indexes where you cover all the foreign key columns. And then also you can create uh, indexing on the composite keys as well. So as I said earlier, indexing creates a pointer value in your database. Hence, instead of scanning all your table, it accesses the pointer, and the pointer will let know the query that, okay, this data is present in here, you just have to scan it there. So you can use indexes to improve the performance, scalability, and data integrity as well. Jumping to our fifth question, given a specific query, identify potential performance bottlenecks and suggest optimization to improve its execution time. So look at this query. I'll give you like 10 seconds to observe this code and try to come up with few bottlenecks that you can find in this code. Okay, so I've hidden it, so make sure you try to find something. I'll give you 10 seconds to do it. I hope you all found something. So let's say what happens here is, I'm having a select query, which is good. I'm having an aggregate function here, and I'm giving an alias name, good. And then I'm choosing the orders table, then I'm joining it to the users based on an user ID from both orders and users table. Then I'm joining orders items with order table based on the order ID of both orders and orders items table. And then I'm using filter, and then I'm also ordering it based on the total that is being aggregated using the value here. And I'm using orders by to give the descending value, and then I'm limiting it to 20 rows. Okay, what are the bottlenecks? Date filter on big table. Okay, because I've used my filter to be a date, what happens is it is going to scan anyway my full table. You know the reason? Because An order date will have low cardinality, right? So the cardinality for date is going to be more for each day. For 10 days you're going to have different cardinality, but in big data you'll be handling years of data. So imagine you're going to have 365 cardinality and you're going to filter based on that. So it is not going to be much beneficial as you think. So rather try to have, try to choose with low cardinality. Hence you're going to have a better filter. So date filter on big table forces the lot scan. The only filter is on orders.order date, right? So all order items and users are pulled in even if relevant, right? And because this is a joint table, we are merging three tables, and we have just used where on orders date, which is in the orders table. We are anyway going to run a full table scan. And as you see here, there is no idea of hints here. So index is missing for the columns that we are using in this query, which is still a talking point. You might, the HR might, or the interviewer might say that no, that's not still valid, but you can say that no, when you provided the code you didn't mention if there is indexed value for any of the columns at all, so you can say that the index has been missing. Then another bottleneck is order by with aggregation. So what you've done, you're running an order by on the aggregated value, which is here. So your aggregate function is sum of, so you're multiplying quantity into the price, and then you're summing the value and taking it as a total column, right? But what you're doing, you're ordering it based on the aggregation there. But this is going to be a very expensive process, okay? And then you're also using limit to 20, and you're unnecessarily, doing a full table scan. So if you need only limit of 20, you're running an unnecessary order by, which is still expensive, and because you're running especially it on a computed column or the aggregate column, okay? And then sorting it or limiting it to only 20 columns after running a huge table is a big no, because it is inefficient. So joins on larger table, we are joining orders, users, and order items, okay? If these tables are large, expensive, joints can be expensive, right? As I said earlier, let's say your table is 1 GB each. So if you combine three tables, it's going to be 3 GB in size. And imagine you're running a query just to get 20 records out of it. So it is very inefficient, right? So do not follow any inefficient practices, especially the join between orders and orders items, which could have one is to many relationship, risk of exploding rows, right? So orders table and order items have one is to many relationship, right? So each order can have multiple items, right? So that is what you call as one is to many relationship. So try to avoid these bottlenecks. And what are the few fixes that you can do? You can create indexes, right? So it's very simple. Create index on particular column name, right? And you can give an alias as well. So your alias or the alias for indexing is, so this is the index name, right? So idx orders date is your index name on the column orders table orders date, okay? For joins, what you can do is, uh, you see here, create index orders user id, and then create index order items order id on the particular table and their column name, okay? The join optimization columns, especially if you use it, it's very beneficial. Materialized view optional for reporting. If this query is used frequently for dashboards, pre-aggregate in a materialized view or summary table. Let's say you're okay with stale data and your only goal is to have a faster or efficient performance, then you can materialize your table or you can materialize your view. The syntax is very simple. You just create materialized view and you run your query and you get your materialized view. We can use explain or explain analyze to check the plan. Okay, so when you run your query with explain, it is going to show you how your code is getting executed. So few things to look for is it how does it scan our data? Is it full table scan, or is it partially scanning depending on my filter or the where clause? Does it use index? And then you can check what kind of joins are happening. Is that a hash join, or is it just looping? So we can try to check if there is inefficient joins in our query. Then you can check if it is sorting on the large result sets. So if it is a large set, then you're going to slow down with your larger table. Okay, jumping to our second part, the data modeling. Explain the difference between normalized and denormalized data. I already gave you a bit of hint on it, but I'm okay to teach you now because it's a primary question in our interview series. So normalized is where you break down the larger table into smaller chunks, and denormalized is where you combine or merge smaller tables to one larger table. So data is split into multiple related tables. It reduces redundancy and improves data integrity. What do I mean by redundancy? Let's say you don't have your data normalized and the table is going to have repeated value. For example, an orders table, okay? It's having an order ID, and then if I don't normalize it, but instead I have the primary ID as my order ID and my my orders ID and my product ID. So let's say I don't normalize it. So for each order, let's say there is 10 orders, and then for 10 orders you're going to have 10 orders ID, and then let's say they all order for the same product, okay, a laptop. And if I don't normalize it, the data is going to be redundant because it is going to show that you're going to have laptop multiple 10 times repeated. And for laptop, what is the price? You're going to have it repeated. What is the spec of the laptop? It's going to be repeated. So try to ensure that your data or your table is normalized. So if you have orders table separate and you have your product table separate, it is going to be modularized, and therefore it avoids redundancy. And then for normalized data, you need joins to fetch your full data. As I said earlier, normalized data has multiple tables splits, right? So you need to use joins frequently to run your query where you have to combine different tables. It is best for the OLTP transactional systems. So when there is write heavy, you can try to use normalized data. Talking about denormalized, data is combined into fewer or wider tables. So multiple smaller tables, you make it as one bigger table. So it also improves read and query performance but adds redundancy. As I said earlier, yes, it improves your read because you're not running joins, but also at the same time you have a drawback where your query performance might be impacted because your data is redundant. It's easier for reporting and because it has fewer joins. It's best for OLAP. So OLAP in the sense it's for analytical. So denormalized data form is mostly implied in settings like data warehouse, data marts. It's for analytics and for dashboard creating or reporting purpose. Okay. What's the difference between OLTP and OLAP schemas? OLTP uses normalized schema to reduce redundancy. Okay. I just explained about redundancy and normalized. So it uses normalized schema. And OLTP, so you can just remember it easy. OLTP is transactional processing. So transactional processing is going to have a lot of reads and writes. So more than reads, you're going to have writes. So OLTP is a lot about writing rather than read. So what is OLAP? OLAP uses denormalized schema. So denormalized is where you combine smaller tables to one bigger one. There are two varieties of schema within OLAP, which is star schema and snowflake schema. And OLAP is specific for analytical queries and aggregations. Okay. What are surrogate keys and why are they used? What is surrogacy? So surrogacy is you get to have something, but rather You use someone else or something or any other thing to create something for you. Let's put it in a plain English. What do you call a surrogate mother? So let's say you have a natural mother, right? Let's say you have your primary or your virginal mother. So instead of that, the surrogate mother would give birth to your baby, right? So the zygote is passed to your surrogate mother. The surrogate mother gets the baby out of her body, right? Out of her womb. So similarly, surrogacy is surrogate key in our term. So you're using an artificial primary key. Let's say you have 5 columns within your table. What can it be? A customer ID, customer name, customer phone number, customer address, and customer region. Okay, what could be the natural key in this? Customer ID, right? But instead of going for customer ID, how you are creating a surrogate key is, for example, let's say you are using auto increment in your database. What happens? The database generates a serial number within your table, right? So instead of using the natural primary key, which is customer ID in this context, you're using an auto increment value. So that is the surrogate key. So the purpose of surrogate key is they are used instead of natural key. And the major benefit of using surrogate key is it simplifies the joins. Also, it ensures uniqueness and isolates changes in source systems from affecting your model. Okay, so these are the benefits of using surrogate key. Jumping to our third session, the big data tools. What is Hadoop and what are its core components? So Hadoop is an open source framework that facilitates the storage and processing of large data sets across clusters of computers. So it's an open source framework that is used for your storage, and then also on top you use MapReduce to process your larger data sets. So it uses a distributed approach to handle your large quantity of data. And you have to remember that Hadoop is not a database. Okay, it is just a storage service. It's a framework basically. So what do I mean by framework? Framework has multiple components, right? So it's not, you cannot say Hadoop is just as one component. So you have to use Hadoop, then you need to have multiple different components, making it as a framework. So, but rather a system for managing and processing data in a scalable way, making it suitable for handling the diverse and massive data volumes, characteristics of big data environments. Okay, in simple, you have to remember that HDFS is a framework that implies your storage and processing at the same time for your larger data set. What are the core components of Hadoop? So Hadoop has a component called HDFS, highly distributed file storage. Okay, so file system. So it's going to act as your storage. And then yarn is your resource management. Let's say your MapReduce needs a processing, it needs extra RAM. Okay, so how does this get occupied? So how does it get employed? So yarn is the one which negotiates your resources. It negotiates between different jobs and then allocates to a particular node or a cluster. Okay, so yarn is used for that, and MapReduce is the processing engine. So nowadays you can say that MapReduce has deprecated, and instead of MapReduce you use Spark, right? So Spark is a process in-memory processing engine. So that is one of the core difference between MapReduce and Spark as well, which we will cover in future. But for now, you remember that Hadoop is an open source framework that has storage and implies processing on top of it for your data sets. And it has three components: HDFS, highly distributed file system, which is for storage, and then MapReduce on top of it, which is a programming paradigm, and that is where your query gets processed. And yarn is the one which negotiates resources between different processors, and or in other terms a node or cluster. What is the difference between Hive and Impala? So these both are the tools within big data technology. Okay, Hive is used mainly for batch reducing. Okay, and the thing is, even with Hive, when you write SQL queries, so the SQL for Hive is called as H Hive SQL, you can call it, or HQL, Hive query language. So however you want to call it, and no matter what, even if you write the HQL, it is converted into map reduce code. Okay, so internally under the hood, what happens is your SQL query gets converted to map reduce query, and that's how your code gets executed. Hive is better for batch jobs, and it also gives higher latency. Okay, but rather Impala, what is Impala? Impala is again a big data technology, but this uses a massively parallel processing engine. In other words, it uses MPP engine. Okay, in Hive you had to convert the code from HQL to MapReduce. When I say you, I'm not saying that you practically write it, but you just write your code in SQL and it gets changed to MapReduce code internally, right under the hood. So similarly, when talking about Impala, you don't have to write anything. It has a native code. So whatever the native code you write in Impala, it gets executed instead of conversion. And Impala is specifically useful for interactive queries. And the reason being, it's a massively parallel processing. So you're going to get parallel processing, and therefore it helps with the faster interactive queries. Okay. You might be wondering, I'm not going to learn these tools. Why am I even getting to know this? But being a data engineer, you have to be aware. What if in the interview they ask you this? You need to ensure that you have a broad knowledge within the data engineering sector. Okay, it's not just that you have just the domain knowledge of what's asked about you, but you have a deep knowledge about all the market trends, the tools within the big data engineering sector. So it's always good to have a broad knowledge. Okay, jumping to our fourth session, the cloud technologies. What is the difference between Amazon S3 and Redshift? S3 is a service within the AWS, the Amazon cloud. Okay, Amazon Web Services. S3 is primarily a object storage system. Okay, it's for storage. Consider that S3. So S3 is abbreviated as simple storage service. Okay, by the term itself you can understand that it's a storage. So S3 stands for simple storage service. So triple S. Okay, SSS. So it's a simple storage. It is schema less. So because it is schema less, what you can do is you can store your structured, semi-structured, or unstructured data as well. And because it can have different formats of data, it can act as your data lake as well. And it can store all your raw data, process data, your stage data. So different benefits using S3. So how is Redshift different to S3? Redshift is a columnar SQL based data warehouse. What do I mean by SQL based? So you use SQL queries to derive data from your data warehouse. And the thing is, for S3 it is schemaless, but rather Redshift is a columnar. Okay, and it is primarily used for OLAP or analytics. So how you can use them both together? You can use S3 as your storage or a staging layer, and then you can either get the data to your Redshift by using copy into command into Redshift for querying, or there's a service called Redshift Spectrum. Okay, so Redshift Spectrum is a service which is a part of Redshift, so you can run directly on your S3 instead of copying the data to Redshift. So that's what I've mentioned here. Redshift Spectrum allows querying S3 directly. But in other simple terms, what you can do is you can use S3 as your staging layer. Let's say your data is coming from different source. Okay, your raw data falls into it. You can process the data and put it in a different S3 bucket. Once it is processed, you can dump those data into your Redshift warehouse, which we can later use for analytics. So jumping to our the final question of the day. How do you ensure data security when working with cloud platforms? Because you're working in cloud platforms, data security is a must. And this is a very common question asked in your data engineering interviews. So make sure that you pay a pretty much more attention to it. You can use IAM policies for role based access. What do I mean by IAM? IAM is identity and access management. Okay. So you defined your roles, you define your policies, and after you define both of these, you attach these policies to your roles, therefore making the role based access a security strategy for your cloud platform. You can encrypt your data at rest and at transit. So how can you encrypt your data at rest? You can use KMS, which is a key management service. So you can encrypt this data and have your key within the key management service, that is KMS, in your AWS ecosystem. Or else, let's say you don't want to maintain your key, you can even ask the server side uh, or the client side. Okay, so the AWS itself, the cloud itself, will have your encryption keys than rather than the client having it. Okay, so you have to block all the public access to your bucket or at account level. What do I mean by bucket? So I was telling about S3, isn't it? So S3 is a simple storage service. So within simple storage service, you have to create folders or buckets. Within these folders slash buckets, your data gets stored. So what you can do is you can restrict or block all the public access to your bucket, and therefore you have only account level access. For private traffic, you can set VPC endpoints, okay, rather than having a common endpoint, okay, to access your data. You can set VPC endpoints. And then one of the major thing is you have to set data masking policies. You can tokenize your sensitive data fields. What do I mean by sensitive fields? For example, let's say you have a PII data. Okay, what is PII? It's a personal identifiable information. So it's going to have the information about a person. So you can mask the columns, okay, because not every team needs to access all the data. So you can set masking policies defined on the roles. For example, the admin team doesn't have to check on all the data, isn't it? They don't have to see all the information. For example, the data analyst team doesn't have to see all the personal information, but the marketing team and sales team, they might be having to use this information, right? So for depending on the team and your business use case, you can set masking policies and ensure that role based access is given. You can set audit logging using CloudTrail. So CloudTrail is where you track your activity for your data access. So let's say someone has access to your data, someone has manipulated your data, someone has deleted your data, or someone has accessed the S3 at all. They have just browsed upon. So this CloudTrail is going to have all your logs stored, which can be used later for the audit purpose. Okay, so auditing is very must, especially working within the domains of data. Provide least privilege and regular access reviews. So let's say a team is asking you to provide a particular access for a role. So instead of giving all the policies or the extreme policies or the admin privileges, what you can give is give least privilege. Okay, what does the user want? Give only that. Let's say he just wants to write the data. You just get to give him the right permission. Let's say he's just going to have read through the buckets. Just give him the read permission rather than altering it, deleting it. So restrict those accesses. Let's say he just want to dump the data within. He shouldn't be reading at all. So just give him the access to put the data within. Okay. So provide least privilege and also frequently check the access reviews for different roles. So depending on the roles, you might be getting updated every day or a week, or depending on the governance policies, compliance policies, or your company policy itself. Different roles might have different access, so it's good always to have an access review. You can enable bucket versioning and MFA delete. So what do I mean by bucket versioning? So let's say today you have certain data and tomorrow you get new data. So what this bucket version will have is it is going to have version of your information. Okay, Let's say for yesterday's version you had 3 files. For today's version you're having 4 files. For tomorrow you might have five files. So each version is going to have an information about your data. And MFA deleters, for example, let's say unknowingly, or I've been very careless, and I've been I've been there to delete the data. Okay, but deleting is a very what can I say? It's an unwanted option or unnecessary option within the data team, because all the data must be secured. All the data must be stored till when we have the storing policy. So deleting a data is going to cost your customer information, or it's going to cost your business value as well. So you always need to have this history of data or your customer information stored, which will be later accessed by different teams. So let's say you have been very careless and you're going to delete your data. So always set MFA, which is a multi-factor authentication. So if you set MFA, the intention is very clear here. You want the data to be deleted, and it is not an you know unnoticed process, or it is something that has happened carelessly, because you're authenticating via MFA, right? So these are the ways you can ensure data security for your cloud platforms. So that is all for today, and I hope you all enjoyed the session. So we are the Data Valley, the fastest growing edtech company of 2025. If you like this content, do drop a like, and if you have any questions, feel free to comment, and do share it with your friends and other people who are aspiring to be a data engineer. And we are Data Valley, and we have our headquarters in UK, in US, in Dubai, and in Hyderabad as well. So get in contact with us if you would like to join our institute. Feel free to reach out the number that's provided in the slide. We provide multiple domains of teaching as well. We have ethical hacking, Java, Python. We have SQL developers. We have data engineering. We have data science. Yeah, we have multiple subjects that you can take